Hello, everyone. Thank you for joining us for today's webinar. Today, we are going to discuss the topic, increased data protection in your automation devices with CIP Security. We are going to understand more about what is CIP Security and how this could help us with the current race in the cybersecurity spectrum. Today, Gordon, the principal technology consultant for Rockwell Automation, myself, Johan Barona, the product manager for automation and networking in NHP. We are going to present this topic and discuss with you some questions around the presentation. Yeah. Before jumping to this agenda, just for housekeeping, please mute your microphones as well and turn off your camera just in case. Yeah. If you have any questions, please just write on the left box that you have there, Q&A. Just write your question there. At the end of the presentation, we are going to answer all the questions. Yeah, because maybe some question could be answered across the presentation. It's much better. This is the agenda for today. First of all, we are going to navigate about the current scenario of cybersecurity in the OT sector. Then we are going to discuss why do we need network security, what is CIP security in terms. Gordon is going to help us with this. How does CIP security link with OT security standards? It's very important to understand what are the global standards and frameworks that are related to cybersecurity and more in our industrial space. Then we are going to discuss how do you configure your CIP security, then CIP security policy management, CIP security use cases. We are going to navigate through real use cases that you can see with some architectures. It's good to know what, okay, from the automation architecture, how you can plan through this CIP security. And then we are going to give you some references and resources. And then we are going to just answer all the questions that you have been written there in the box. Let's start it. Let's start for this. What is the current scenario of cybersecurity in the OT sector? As you know, like in the last months or last year, some commercial companies like Medibank and Optus have been hacked. From some statistics, after the pandemic, these cyber attacks have been increased like 600%. And why? Because cybercrime pays, and it's only getting worse. Yeah? And our industrial companies are prime targets. Why? Because what happened with Medibank, Optus, and other commercial companies, hackers had been stealing information. I am a Medibank customer. Across that time, like 2 weeks after that, I received some advice from Medibank. But after that, I received some messages in WhatsApp, calls, and emails, just trying to just get more information for me. Yeah, but that was just information. But in our sector, in the industrial sector, that will be worse because we have production lines. We have automation that control entire systems. Yeah, and if people or external parties get control about that, that could mean a downtime, or maybe impact the quality of the products, or maybe the safety as well of the operators or people that live nearby the factories. What is the spectrum? Why as well we are targets? Why the industry is a target? Because in our industry we have legacy systems, and the old legacy system, they don't have the technology of the upgrade to counter for this kind of acts, yeah, or new technology from these cyber attacks. Some of these legacy systems are unpatched infrastructure. As well, the other thing, across the last 10 years, we have been installing these IoT devices that have Ethernet connectivity. Sometimes we can't control who is installing this, because in an end user or in a factory, there are a lot of contractors or external parties that are working there. We don't know sometimes what is installed. Yeah. The other thing, okay, something say, please fix the camera frequency. Okay, sorry. I'm gonna read that. The other thing is like sometimes we don't have maybe deploying an asset inventory. We don't know what we have installed in our factory floor. Yeah. On top of that, in our OT system, we have a skill resource that a lack of skilled resources. We don't know, we don't have the skills of many of the IT managers, yeah, that have been just handling this for more time than in the OT environment, yeah. In the last 3 years, 61% of industrial manufacturers have experienced cybersecurity breaches, yeah. And every organization is vulnerable, yeah. 60% of the cyber attacks go undetected, yeah, and most organizations aren't prepared. Yeah, what's happened in our industry? The hackers, they know that they need to learn. They install malwares that can last months. Meanwhile, they are learning about our automation systems. They are learning about how are our processes, and then just devise or just to identify what is the perfect time to create that harm. Yeah, and it's expected for 2025 that estimated cost could be $10 trillion annually. Yeah, and we must be proactive around this. But let's continue with the next slide. But what is happening with the government, with Australia and New Zealand? Let's start with that, because some people say, okay, this is too wordy talking about cybersecurity. A lot of companies are just creating the fear about cybersecurity, but what is the government posture? What the government is requesting? I don't know, you have been reading about the Cybersecurity Infrastructure Act for 2018 in Australia. This act also just outlines how the government can support companies if an incident occurs in the critical infrastructure. Yeah. At the beginning, they are focused on critical infrastructure sectors. It means communications, defense, food and grocery, energy, transport, water, and wastewater. Yeah. But what are the company obligations? If you are in this sector, what are your obligations? Before 18th of August of this year, those companies must have a critical infrastructure risk management program. In other words, must have a plan in place to face these cybersecurity risks. Yeah, and these how the government is advising people is going through global standards that we are going to see in the next slide. And how New Zealand is working around this. The National Cybersecurity Center is working with the NIST, yeah, with the NIST framework. It's a global framework that is from US. It's from the National Institute of Standards and Technology. This framework made the life easier for people, for the companies to start to create this policy or this cybersecurity plan. And they were from 5 items, like how to identify, how to protect, detect, respond, and recover. And New Zealand has been working their own framework in a parallel way, very aligned with the NIST. Yeah? But if we compare with Australia, New Zealand is just making this mandatory for government agencies. Australia is making this mandatory for those critical sectors. Yeah. However, in the future, could be like Australia could extend that for more sectors. Yeah. In this case, for New Zealand, other organizations that are outside the government agencies, they need to go to the maybe should consider as best practice. Now the question is how NHP could help you in this case. It's like you have a complete portfolio aligned and certified with the most robust industry standards and frameworks. Yeah, We are aligned with the ISA 62443. It's a global standard. As well, we have been aligning our portfolio with the National Institute of Standards and Technology of Cybersecurity from US. In this case, more from the services. We have services, hardware, and software. Yeah. Today, the goal is our focus will be more on the hardware perspective, how you can protect from the device level, from the automation system, and have this data protection that is the main topic for today, and protect your automation systems and networks from the CIP security protocol that we are going to discuss with Gordon. As well, how you can put in place some architectures and start from that point and deploy within your automation systems. Now I'm gonna hand over to Gordon. He's going to start helping, he's going to help us to understand why do we need network security. Thank you, Gordon.
Good morning, good afternoon. Traveling along on the same theme that Johan's put out, just a little bit more as a lead-in, but these are US numbers in US dollars. This is from a 2021 report of the costs of cybersecurity, to the global economy, whatever. But I want to bring them back down to a bit closer to home and to an Australian perspective. Sorry, New Zealand, but I haven't found numbers for that as well. But this is from the top one is from a 2023 source. If you want to know the sources for any of these numbers, please just drop us a line, and I'm more than happy to pass on the references for these numbers. But so they're saying, cybersecurity's cost us about $42 billion. Cost to Australian business is about a $29 billion. That's actually a 2021 number. The average cost of a data breach is actually a 2018 number, from Frost and Sullivan. And then the rest are actually from the Australian government, which are again 2023 numbers. So that gives you a sort of a bit of an insight to the costs of an incident. There's also a very interesting report available, which is an IBM cost of data breach report, which came out in 2023, which breaks the numbers down a lot further. But obviously, the cost to the pharmaceutical sector is a lot bigger than a lot of other sectors. So anyway, if you want to look down those numbers, but so when we start shifting gears a bit just to in industrial environments, as you know, a lot of you or a lot of sites actually have legacy systems installed. Systems have been installed for many years. Their programming software and their HMI systems are running on maybe even operating systems that are long out of date. May not even be running an antivirus system. They may not be running anti-malware systems. They may not be patched to being patched because that this thing called risk that shows up in industrial environments. So, sometimes you don't want to, if you patch it, you might break decom or something that breaks your HMI, or there's a whole lot of stuff that comes into play through the installed base we have. There's also obviously the OT versus the IT space is a little bit different on, they can shut things down as we want to keep things running, and there's a whole lot of other stuff that comes into play. But there is specific challenges that we have in the industrial environment versus what the people in the IT space actually have. Okay, so what's at risk? Well, this is a pretty heavy sort of a slide, but there's a lot of things that are nasty. But probably the best things is loss of production or unscheduled downtime. I don't know what the difference between these two is supposed to be, but to me they're one and the same. But Okay, so there is there's obviously a lot of risk to our, machines, property, production, and also reputation, brands. There's a whole lot of stuff that comes into play, which are tangible and intangible risks. So why is CIP security important? Well, as you know, historically, the protocols that we use in industrial automation systems don't have any security. Well, what we mean by that is there's no ability for the protocol to protect itself against intrusion. So the protocols like Ethernet IP, Profinet, Modbus, etc., inherently when they were brought out, they didn't have any security protections in there. And now we have all these standards coming along, and the current big one is the 62443, which grew out of ISA 99. There's a need for us to be able to protect the protocol. Okay, or protect the network, or have some protection where the devices can protect themselves. Okay, so the next question is, well, what's CIP security? So I guess I answered it. Well, CIP security provides secure services to the Ethernet IP protocol. So Ethernet IP protocol is obviously the main protocol that Rockwell Automation uses at this point in time. I suppose I should spell out that Ethernet IP is sort of the brand of the protocol. We use a thing called Command Information Protocol, CIP, in that, and there's a whole lot of subcomponents in there. You've probably heard of CIP Safety, which is adding the safety protocol onto Ethernet and being able to do it deterministically, adding CIP Sync, being able to sync devices up, CIP Motion to be able to do high precision motion control over it. CIP Security adds services to secure the transport of the data. So it's about the device starting to be able to protect itself from malicious communication. So fundamentally, in the past, the way we've protected stuff is by isolation. We've isolated the networks from the IT space. We've had islands of information disconnected, of control systems disconnected. So when Industry 3, 4, 5, 4.0 sort of come through, they sort of say, well, you've got to hook your plant system to your business systems to get business value. Well, then that opens you to the business systems being open to the web, and so therefore there now can be possible paths down through firewalls and etc. like that, and plus there's obviously the internal issues with USBs and all that sort of stuff. But where we're going to focus on now is really how does CIP security work and what's it about. So the first thing about it is we talk about authenticity. So what's authenticity about? So authenticity is about the ability for the device to know who it's talking to. So I'm talking to you. Before what we do when we negotiate the connection between us, what we'll do is we'll use either two technologies, one called certificates. We'll exchange digital certificates and use that for authentication, or you can use a pre-shared PSK, a private key that we can set up. Certificates are recommended because keying, when your system gets larger, keys can get difficult, and I'll talk a bit more. I might mention that when we talk about zones and stuff a bit later on. Okay, so authenticity is about I know that who I'm talking to, and they're a trustworthy device. Okay, they're a trusted device. The next area that when you turn CIP security on is you get integrity. Okay, so integrity is about that when I'm talking to a trusted device, okay, to that trusted device, how do I know that the information hasn't been altered? And what we do is we add a thing called a hash algorithm or a hashing key onto the transmissions. It's a thing that's negotiated between the two trusted partners or the trusted partners, and they will use the hashing algorithm to hash the communications or include a special integrity checking in the communications. So no man in the middle person can start to intercept packets and then timely be able to modify them and send them on as valid packets. So integrity, prevents, will cause the receiving device to reject anything that has been altered. Any packet has been altered to be rejected, and any packet is from an unknown identity be rejected. Okay, and so in the last area is confidentiality. Confidentiality is where we actually encrypt the actual packet. Okay, we add encryption to it, so people cannot read the contents. So we secure the contents. It's not something we really need in automation very often. Okay, we need to know that who the person we're talking to is trusted. We need to know the packets have been modified. We don't normally need to encrypt the packets, and I'll talk about in a moment why we don't always just want to turn confidentiality on just to say okay, whatever. But confidentiality, I guess, it just broadly has overheads that come with it. Okay, and I'll talk about that a couple of slides on. But but if you were transmitting your secret herbs and spices or your recipe for Coca-Cola or whatever, and you didn't want anyone to be able to watch that, well, then you'd turn encryption on. But any other instance, we don't recommend using confidentiality because of the overheads associated with that. Okay, so just a bit of a sideline. Well, what technologies does CIP Security use? Well, it's no different from the technology you're using with your web browser. So when you're in your web browser, you go to a banking site or something similar, it's a HTTPS, which is connection. You get the padlock or whatever similar showing up saying that it's a secure connection. We're using exactly the same technologies. Digital certificates, hashing, but they use encryption all the time, but as well, so they encrypt the communication. So it's exactly the same technologies just being employed to the industrial protocol. So nothing new, nothing different. Okay, so what am I actually securing with CIP Security? Well, you're actually securing the logical Ethernet port in the device. Okay, so if it's I'm going to use some terms like if it's a Ethernet card, like an EN whatever T card with two ports on it or a single port, it'll lock. You lock the logical port. Of course, you have one IP address across, and it's you've got basically a two-port bridge going across those things. You're locking basically the virtual port heading from those connection back into the device. But in the case of a compact logics with two ports and you have it in dual IP mode, you can only lock today one of those ports. The other port, which is normally considered the outgoing port, but at this point in time, if that's locked, you can't lock the other port. You can only lock one or the other. That will change in the future. There's some technology issues with it at the moment, but they will be resolved and move forward from there. Okay, so this is the slide I was sort of hinting about, is about some performance considerations. Okay, so I'll start on the bottom right here with an Ethernet, which is an EN4T card. You can see that down the bottom right corner, you can see that the packet capabilities per second So without CIP security, you can see this card can do 50,000 packets a second, okay, of IO packets, okay? And when I turn on CIP security, so I turn, after I've done the negotiations with I've done the authentication checks, and now I'm using integrity on all the packets, I now halve my performance through that comms card. Okay, that's the overhead of adding the hash checking, the hashing algorithm onto the thing. And then if I actually encrypt and turn the encryption on, confidentiality on, you see my throughput drops to 15,000 packets a second. And on the chart at the bottom on the left-hand side, on the right-hand side, you see from HMI perspective, so 3,700 without CIP security packets a second, 2,700 with integrity, and 1,700 with integrity and confidentiality. So this sort of tells you a bit about, okay, well, why do we have CIP? So why don't we have CIP security and add it to legacy systems? And the reason is that we don't have the horsepower in those systems to be able to execute CIP security. Okay, so we require storage and secure space to be able to store the certificates securely on the device, and we also need to be able to have the horsepower to do the real-time packet encryption rates. So you can see that it has quite an impact. So how do you know how much impact does it have on your system or whatever? Well, we suggest you use our tool called IAB, Integrated Architecture Builder. If you go in there, put your system in it, with all your devices in it, CIP security works on a connection basis, so it encrypts you on each connection to decide on what it's going to do and what it's going to use on that connection. So you tell IAB that you're going to use CIP security on some of these connections to these devices, and it'll take into effect and tell you if you've got enough throughput to reach the RPIs you require, the update rates you require, the HMI performance you require, et cetera, et cetera. Okay, so I'm going to change tack a bit and then talk a little bit about how does CIP security link with the OT security standards. Well, CIP security, when we look at the CIP security and using it here and how it applies to the standards, we got to, first of all, I guess you got to understand what risk you're trying to mitigate against. On the right-hand side, we've got the defense in depth model. Just because you're using CIP security doesn't mean you ignore defense in depth. Okay, defense in depth means you build layers of an onion to protect your systems. Okay, you have a controller, you may have CIP security turned on, but you still lock out any ports in a switch that are in that cabinet with the controller. You lock the door of the cabinet, you lock the switch room up, and with an ID card system. So you don't leave Studio 5000 logged in and open in the substation that has auto timeouts enabled, so it times out. Your network is running, you've set up MAC lists and access control lists and stuff like that, et cetera, up the onion. So if someone breaches one level of your defense system, they hit the next. But CIP security ultimately is about the last level of defense. And it aligns with, this all completely aligns with the standards because of, it's basically, a lot of it's built based on the NIST framework and stuff that's come out of Department of Homeland Security in the US and a whole lot of other organizations. But anyway, I'll talk a bit more about the standards as we go through. So on the next couple of slides. So I don't know if you heard the word NIST being used in the opening. So the NIST framework, it's a voluntary guidance system developed by the US government. It's based on all existing standards, guidelines and practices for organisations to deploy cybersecurity and manage the risks associated with it. It's a comprehensive framework which you should download. This month, the version 2.0 is due to come out this month. I haven't seen that at all. I saw some of the pre-work about it, but but it enhances it further and ties it closer in line with 62443, which we'll talk a bit more about. But there's three main areas of NIST, and the framework, but it's about the core, the implementation, and tiers and policies. I haven't got time to go through it any here, but I just urge you to start learning about the framework, because it's more than just applying a CIP security protocol or saying I want 6243 certification in my system. Oh, I thought this slide was hidden. Actually, I didn't expect it to come up. Anyway, okay. So anyone who's doing safety systems and they need to apply to 61508, or they're doing a process system with 6511, 61511, I should say. They both have been revised a few years back, where they've added that you shall consider cybersecurity as you implement your safety or your process systems, and it says you shall mitigate the system from cybersecurity. It references a standard from memory, TR 84.00.09, I think, about how you go about accomplishing that, and then which is also aligned with, and you'll find, but it basically then goes on and says you shall use you shall be in line with 62443 standards. So anyway, I didn't expect that slide, but if you're going to head into doing a safety or a process safety system, you definitely need to consider cybersecurity now to be in line with the standards. So 6243 drives our Rockwell's cybersecurity standard, and it also does it with all our competitors. So everyone's become aligned and based on 62443, and then under the 27001 and the NIST framework. So they all tie together. But I'm going to push ahead here a bit. So CIP Security, I told you, it's the last line of defence in the defence in depth strategy, which is defence in depth is spelled out by all the standards organisations. So the ODVA is the organisation that runs or owns Ethernet IP protocol. There's lots of members. Rockwell's one of those members. Snyder's a member, Omron's a member. There's a whole lot of people are members. Anderson House are a member. There's a whole lot of weird and wonderful organisations that are members. And they manage the CIP security protocol as an open protocol. Is all I'll say at that point in time. And their intention is to keep it in line with 62443. From a Rockwell perspective, Rockwell's product certification is to the standard, the Part .4.1. Just about all us and all our competitors are that, but we are at the highest level, level 4. I think with any vendor is actually at the highest level regarding our product development. The next area is the product capabilities, and it's the 4-2. Well, Logix was the first certified controllers to the -4-2 standard, and then as you build up systems and industry solutions like the process, the -3. But if you're a system delivery organisation, there's a whole lot of stuff like 2-4 and some other areas like 3-2 and stuff that are about delivering a secure system. So I see sometime in the future people delivering cybersecurity systems will have to have mandatory certification to be certified ability to deliver certified systems. So Okay, so how do you configure CIP security? Okay, so there's a bit of software called FT Policy Manager, so Factory Talk Policy Manager. It's a free bit of software. When you install Factory Talk links or the Factory Talk platform, you go into the customize it. You can say I want you to install Policy Manager. So Policy Manager is a free bit of software that manages CIP security. Okay, so in line with 62443, there's these things called zones, conduits, and devices. And I'll talk about that on the next slide. The next slide's more. But you create things called zones of trust. You create policies, and you bring stuff in. So, but segmentation, just like you segment networks, you learned how to segment your networks for because of broadcast domains. You segment your network down. You do the same thing with security. You segment the areas. They run their own security key system that's independent. You don't use the same key typically across the whole system, because then if you breach one area, the whole lot. So you break your system down into zones and stuff like that. So Policy Manager, it's a pretty easy bit of software. It auto discovers everything out there. You then go into zones. Okay, you drag into the zones the devices you want in the zones. Then you create policies on those zones. So you turn on certificates or keying, you turn on integrity, or do you want confidentiality or that sort of stuff for that zone. You enable or disable port 80 and stuff like that in there, and then you then start creating conduits between zones, and I'll make some sense of this in the next slide. Okay, so here we've got an example. I've got an architecture of the site. So I've got zone 1 here. So in zone 1, you would drag in these devices in the Policy Manager in this area here. You would then say what type of security you want things. Then you'd actually push it out and deploy it to these devices. You go to another zone, you create this and segmenting it up. There's another controller. You'd create it in a do the same thing again with it, and you'd push out the policy for this area down for this area. But then if you want, here in this example, they've also created a PC zone where you may have programming terminals, HMIs, asset center, so asset management. You may have historians, you may whatever you have up in the PC zone up there. You create a zone up there and then for these zones, the devices in the zone can talk to each other quite happily. But to be talked between zones, you need to then create a conduit. Conduits can go from zone to zone. They can go from device to device, or they can go from zone to device. So you can create the conduits in 3 different ways. Okay, so if I wanted then my PC zone, the HMI up here, or the engineering station to be able to talk to this area, you could either create a conduit directly from the programming terminal to the controller. That means everything else it can't see. But if you had drives and things you want to see drives and things like that, or download to the panel view, well, you'd want to maybe zone from this programming terminal to there. So again, it's like having a VPN tunnel between the zones or between devices. If you wanted this controller to talk to that controller, you would then create a conduit between those 2 controllers and those more controllers, and then they can talk to each other between the zones. Sorry, I'm pointing to zone 1 and zone 2. I don't think you can see my mouse. Okay, so CIP Security Policy Management. So what's this about? Okay, so policy management, part of 62443 is to be compliant is devices have to have syslog auditing, or have to have an auditing function. So everyone uses syslog. Syslog's the preferred method. Policy Manager, Factory Talk Policy Manager does not add audit log messages. The audit log messages are have to be generated from the device themselves. So So whether the device actually has syslog capabilities depends on the device. In our space, basically everything we do does have the syslog capability. I think everything that's compliant anyway has the syslog capability. But policy manager will attempt to configure it for every device. So what it means is that if you know what a syslog server is, hopefully the devices will send any security related audit messages straight into syslog. Okay, hopefully that makes some sense to you. But okay, so what I want to talk a little bit about the policy management. I talked about pushing policies down, and in fact, that until a year ago, that was the only way you could manage CIP security, was that you would push the policies down. So what's the problem? It's a little bit. Let me use another analogy. Is anyone familiar with our automatic device configuration capability of our drives and E300s and stuff like that? Is that if you have a drive and the drive has the magic smoke come out, and you've got to get the magic smoke back in again. So you've got to replace the device. So when you replace the device, people then need to know, well, how do I get the IP address back in that device? So when you put the IP address back in it, so our static switches allow you to do that nice and neatly. They'll automatically put the IP address in it. So that gets you back up and running. But now you've got to set the parameters up, the speed and everything for the base speeds and everything like that, from the settings, the current limits and everything for your drive. So you either got to go over find a computer or a laptop, plug it in, download it, etc., or if you have automatic device configuration set up, the controller will now push the parameters automatically back in that device, and then that device will come back online automatically. So up until a year ago, the problem also was with CIP security. So if you had a secure device go down, the only way to actually recover it was actually to manually push the policy back out. Okay, which means that you need to train your people in a whole lot of stuff. Okay, same as replacing a drive. So what came in 6 months ago or 12 months ago was actually this automatic policy replacement. I'm just going to talk about these two workflows a little bit in the next couple of slides. So on the first one here, we've got, okay, if it's the manual workflow is, if you lose the connection, so the connection to the device goes away, so you replace the device with a new one. So replace it out, put a new one in, and then you have to open up FactoryTalk Policy Manager, push the policy down to that device. So the certificates, the keying and the hashing, all that stuff that it needs to do it to initiate the device before you can then, that device becomes operational. So it was another step was needed to get it back into operation again. Okay, so obviously there's some issues. I mean, there's obviously learnings and stuff that comes along with that. So what's now come along is automatic policy deployment. It won't work on if you add a new device. So if you're adding a new device to a network, say I want to add a drive to this network, first time up, you manually would have to go in, use Policy Manager to set that device up, add it to the control system, and away you're running. But once you get it up and running and the network is running and you've got security running in it, you can then use an automated workflow, which is this automatic policy deployment. So to actually use this, you need to have Policy Manager added onto your FactoryTalk directory server, wherever it happens to be in your system. So once you have it, then it has a bit of a system here that you bring the new device along, you add it to the network, it then authenticates itself against the FactoryTalk directory. So with certificates, it says that certificates are valid, so the directory holds all that stuff for you. Then it will move it saying it's a valid device. I can move it, so authenticated, trusted device, move it to the onboarding area. Then we set about actually merging that into our configuration. So it will merge it, but it still hasn't been deployed yet. And now it says, do the IP addresses match? If they don't match, well, then I need to, if they don't match, I need to push push, I need to have the Stratix set the IP address up for me, or manually you need to set it up, and then you can push it to deployment. But it's a little bit like when you have an I/O or device on the I/O tree of a Logix controller, is that there's a whole lot of keying then that comes into play. So the keying can be, you set it up, you can say it's got to be exact same type device, it's got to be the same, it's got to be from a trusted vendor as a big thing, or it needs to be, you can say, oh, it's just got to have the same IP address, and we'll try and then set it up, etc., etc. So, so then goes through a keying system, and then it'll automatically add it in and then put it online. So again, it's about making it much easier to live with this technology. One other side comment I'll make here before I just get into the last little bit is the CIP bridging. So as you know, we have a control logic system, or a Rockwell system. If you have 2 Ethernet cards and a chassis, you now have bridging between those networks. It's just done between the cards using the backplane. Okay, there's no way to stop that using anything other than CIP security. So if you turn CIP security on, you can actually block from coming from a secured network out an unsecured, or you can now allow that. You most likely allow that. You most likely allow outbound communications from a secured or unsecure. But what you don't want is communications coming from an unsecure back into a secure. So you would block that using a policy manager. Okay, so my last area here, the main big one, is just some CIP security use cases. So, so the current products that we have that support CIP security, it's all the L8 based Logix family. So the 5580 controllers, guard Logix and control Logix, the compact Logix, so it's the L8 based compact Logix, the 5380s and the compacts, and all includes the process versions and the extended temperature versions and all that. The Kinetics, some of the Kinetics drives, some of the PowerFlex drives, both low voltage, medium voltage, and the armored on machine stuff. And then this thing called a proxy server, which I'll talk about in its own right, a couple of slides on. And the other big one is Factory Talk Links. So these are the current products. You'll see, Flex 5000 IO adapters, and you'll see a whole lot of other stuff come through in the future. But this is currently, as this moment, of what supports CIP security. So some use cases is that, so if I have a control Logix controller, I can secure a network by, as you said to it. But in here, you can see I've got some point IO, which doesn't support CIP security. So you have a facility to actually do a thing called whitelist. You can whitelist that device, so that connection will not be secured. So if you turn CIP security on, the devices that support it can use it. Devices that don't will still just talk the current way until they do. Okay, hopefully that makes some sense to you. Okay, so if we have a control Logix, since you can see the standard control Logix since version 32, or guard Logix since version 34, they have native CIP security, but both of them only got 6243 certification in version 34. So if you need 62443, you need to be version 34 above on the control Logix. But again, same thing. It can have secure connections, policy manager and then also up into links, devices and systems. Compact Logix, much the same, except Compact Logix has got CIP security in version 34, but they've only just got certification to 6243-4-2 in version 36. So if you need 62443 certification, you need to be version 36 and above, okay, to support it. But again, it can, on one of its ports, it can talk quite happily to other secured devices. Okay, the EN4TR also supports CIP securities. If you have a version 31 plus controller, it can be an L7 based controller. It can use the EN4TR to actually get CIP security into the rest of the system. So as long as it's V31 on an L7, it can talk CIP security, or you can also use it to add more ports to a 5580 and secure it besides the local port. Okay, so this one here is where we start getting interesting. So I really want to have security to this point IO. It's a legacy IO. hasn't got enough CPU or horsepower to do CIP security. What we can do is put a device called a CIP security proxy, which is a bit like an ETAP. It's a 3-port switch device. It has the DLRs out the bottom. So in this case, we're only using one up the switch, but it supports a DLR at a gig, and it also has a gig connection to a device. And in this case, it's the point IO. So we can put this device right next to the device, have a very short unsecured link between this device and the point IO, but then the communication from the switch to this device is secure. So if this device is out in the field, you want to secure the comms to the legacy device, you can use this thing called a CIP security proxy. Okay, so some other use cases. So if you have a controller that doesn't support CIP security on its ports, you could put the security proxy before it, and you can use a security proxy for engineering software. You cannot put a HMI out here today. You can't put a HMI talking via links, which is secure, to the security proxy and talking back. So it's a problem with a thing called unoriginated connections. But anyway, I won't get into it here, but at the moment, it's only the engineering software that's supported. So you need secure programming, and the same applies to a control logics. If you needed another secure port out here, you could quite happily do the same using a CIP security proxy. Okay, so my last slide here is about FactoryTalk Policy Manager and OPC UA. I don't know if you know, but version 36 of Logix came out a month or so back. And what version 36 of the firmware added for the L8 controllers only, base controllers, where they're control logics and compact logics, it enables OPC UA on the front port of the controller. So it supports both Ethernet IP on the front port and OPC UA on the front port. For a small, I'll just say off the sideline here, for a small system, all good. But for a large system, at the moment, Ethernet IP is recommended over OPC UA. So don't move everything you've got over to OPC UA today. At the moment, the current implementation can you set the port up as either a client or a server. It can't be both today. Next version it will. Okay. At the same time, the next version simultaneously will be client and server. Anyway, there's a whole lot of stuff in the knowledge base on how you go about doing that. But because we've now added OPC on the controller, what's important about this is that they've enhanced in the latest version of FactoryTalk Policy Manager 6.4 and above. It supports, which I should say on the slide here, but I don't. It supports managing OPC UA security, certificates and encryption and stuff like that, turning it on and off. So you only need one bit of software to manage that security. Also, if you have third-party devices using OPC UA, the controller's talking to other devices, you want to manage the security in that, Policy Manager can do it as long as the devices adhere to the OPC UA security spec. OPC UA does not have 6243 certification at this point in time. It doesn't have that necessary stuff to get that level yet. One day it will. One day maybe OPC UA will be the network of choice in automation, so industrial automation. But there's some water to pass under some bridges before we get there. But maybe we're on that journey. But anyway, what we're saying is Policy Manager will let you manage in the future all your security needs. Okay, well, so this is my summary slide. So what's CIP security? It provides secure transport for Ethernet IP, allows a device to protect itself from malicious communications. It'll reject everything that it doesn't like. It allows you to set up authentication, to know who you're talking to, set up integrity so that the packets can't be messed with, and if you really have to, turn on confidentiality, which again we don't recommend until you really have to. For a PC, not a problem, but a controller, it has a hit. It reinforces the defense in depth. It is not the only strategy. You still use all the other strategies, and it provides good security for the data on the network that's moving. And it has in place all the hooks to allow you to get a system certification 62443-3-3 or similar. Okay, so that was my last slide. There is some references here that you'll get when you get the presentation to documents. This CIP Security with Rockwell Automation is a very good document. If you really want to get some in-depth information about it, way to go. Okay, back to you, Johan.
Okay, thank you so much, Gordon, for the presentation and help us to understand deeper about CIP security and what that means in the automation layer and the device layer, and as well how that is tied to the global standards. We have some questions here. I'm going to read the questions here. The first one is like this one. Can CIP security be linked to VPN, Gordon?
CIP security is it doesn't really it's securing the connection. Okay, so if the end devices are on either end of a CIP security and it happens to be going over a VPN, VPN is just going to add encryption on top of the encryption, I suppose. But I can't see any reason why it wouldn't work, because it's like CIP protocol supports wireless. We do everything between the end devices. So and safety we do it between the end devices. So what's in between, I think, is as long as the VPN gives back exactly what was put in. Okay, so if it encrypts it and it unencrypts it at the other end, you get back exactly what you put in, it'll work.
Okay, thank you, Gordon. The next question is, what happens if you lose the computer hosting the factory toll policy manager, or the backup of the computer is not current? Can the
once you've pushed the policy out, okay, once you push the policy out to the system, a policy manager is no longer required. Okay, so it's stored with the project, stored with the devices, the certificates and the keys are all stored with those devices. It works, doesn't need it. So I've got a dog bark. I don't know if you can hear it. I've got a dog barking in the background here. But he's putting me off. When it's on the directory for backup, obviously, or policy manager files, you need them either the policy manager stuff on the directory to be able to automatically destroy the policy, or you need it in a standalone policy manager to be able to push it back out again. So, but for your plant running and whatever, and when you save your projects, all that stuff stays with it. So you don't need it in the running project. It's only to deploy, set it up and deploy it.
I think that answered as well the next question is, can the factory toll policy manager rebuild from uploading from the network? I think that answers.
No, you can't upload the policy out of the network. It's not like source code. It's source code down, not source code up. You can't pull it. It's not like uploading a ACD file. So I'm just going to open this door up. Sorry, I shut the door and locked the dogs out. It was a mistake. It uploads. Uploading an ACD file, you get back your source code. Policy manager down's not. So you have to have the policy. So if you lost your policies, you'd have to recreate them again and redeploy and push them out.
Okay. The next question here is, what kind of detection security is logged, and does it notify the detection?
Yes, or if it rejects anything, for any reason, it will send an audit log message to the device. If for some reason some device tries to connect to it, if something tries to connect to it and it's not a device it gets packets that have been messed with or whatever, it will notify, the devices will notify syslog. We'll send them to this syslog. So,
okay, sorry. The next question is, what is used as a certified authority?
Is this for certificates? I assume, is it?
Yeah, for the certificates. Yeah.
So certificates, they've got to be digital sign. But as I say, the factory talk directory becomes in our system, that becomes the authority system. When you saw when I added a new device in it, it'll authenticate against the factory talk directory. So when factory talk directory has policy manager installed on it, it'll check the certificates if possible against what you've set up there. But if you're not using certificates, you're using just keys, where obviously is just using the key signatures. So I don't know if I'm answering that question. I'm not certain if I've answered the right question, but I'm happy to take that via email or whatever, if somebody wants to talk more about it.
Okay, the other questions I already answered, because those were answered across the presentation. Some people asked about what are the portfolio from Rockwell that has CIP Security. Already we answered those questions through the presentation. Yeah, and as well, we hope to deploy the policy with or examples of architecture. We already mentioned this through the presentation. I think that we don't have more questions here. I think with that, we will wrap up the webinar. Thank you everyone for joining us today. We are going to send you the presentation and the resources, as included the NHP Safety through Security brochure that contains a lot of this content, and as well some links to video that you can get at, this is from ODVA that explains as well CIP Security, if you want as well another sources, as well all these documents, resources from Rockwell. You could have those from after this webinar. We are going to email you that information. Thank you for having us today, and have a great day. Bye-bye.